So we've got a graph, and we're going to sketch and label its image after we do two things: a vertical compression by 1/3. So that means what we have to do is multiply y by 1/3, and then we're going to move it 2 up. So what we're going to find, like we did in that example this morning, is that when we have stretches, compressions, reflections, and translations, we're going to do those two separately. So we're going to take the key points that we have on this graph, and there's 4 of them. So we've got -5, 3, -2, -3, 1, 0, and 4, 6. And when we set up our arrows to see where those points change, we're going to do 2 sets of them. Well, I would like, whenever you're doing any kind of stretches or reflections, those will be first, and translations after. And you're going to find, and I'll show you why in this one, you first have to do y by 1/3, and then you're going 2 up. So 2 things are happening to y. And your chances of making a mental math error, if you do them all together, they increase quite a bit. Especially when there's going to be times where you do something to x and to y, and then something again to x and y, and it might just be too much information to hold. So this makes it simpler. It is a little bit of extra writing, but it doesn't take that long. So we're going to multiply our y values by 1/3, and we'll see where each of these points go. I mean, each of these points as well ended up with nice whole numbers, but sometimes you might have fractions, and if you're trying to remember that in your head as well, that could get complicated. And then after we've multiplied everything by 1/3, we're going to move things 2 up. And we can plot each of these points. So that point is there, -2, 1. Oops, yeah. 1, 2, and 4, 4. If we look at our final graph, does it look like it's been compressed by 1/3? It does look more squished than the original one. And then it has been moved 2 up. Now, before I give you your homework for this one, I also want to go over, I'm going to first, before we go to the next one, I'm going to write the equation of the blue one in terms of g, just for practice. So if you've multiplied y by 1/3, that 1/3 would be outside the function in front. Then moving up 2 units would also be outside the function. So this is what the equation of the blue graph would be in terms of g. So before we go on to the next one, I do want to talk about the example right beside this as well. And you don't have to write anything down, but I'd just like you to watch. This one is dealing with all horizontal stuff. So the work is going to be identical as a starting point. We've got our points, so -4, 3, 0, -2, 2, 5, and 4, 2. We're going to look at what happens after After 2 transformations, we have a horizontal compression, so that means we're going to be multiplying our x by 1/2 and then 3 to the left. So again, your first set of transformations is always going to be stretches, compressions, reflections. Your second set here is always going to be your translations, left, right, up, and down. And so if we multiply x by 1/2, we'll have -2, 3, 0, -2, 1, 5, and 2, 2. And then moving it 3 to the left, negative 5, comma 3, negative 3, negative 2, negative 2, comma 5, and negative 1, comma 2. Plugging those points in. Oops, one point was labeled wrong. Negative 3, negative 2. So everything up till now is identical to the ones with the vertical. We just did the points. We did 2 steps. Everything's fine. But what I wanted to show you is how do we write this? And I'm going to write it down in 2 different ways. And I want you to guess or think about it and try to figure out which of these 2 ways is the right way. So method number 1, I'm going to say, now this function was f of x, so in terms of f, how do we show x by a half? That would be inside the function. So we'd have a 2x. And how do we show 3 to the left? That would be plus 3. So that's method 1. Method 2, we show the 2 inside the function, but then we add an extra set of brackets for the x plus 3. I want you to notice that these 2 are not the same. Because what would happen if I distributed this 2? Right, this is the same as y equals f of 2x plus 6. So here we have 2x plus 3. Here we have 2x plus 6, or 2 bracket x plus 3. One of those is the correct way of describing the blue graph, and one of them is not. So make a decision, decide which one you're going to pick. If you're just like random guess, or if you think you know based on what you think is reasoning, go with that. But just take some time to think about it. I'm not going to have a show of hands or anything like that. Okay. So some of you picked this one. And in picking that one, you probably went, you know, I like that one. It's got the plus 3 all by itself. It's got the 2x by itself. It's what my gut is telling me to pick. And I don't like the one on the right because it's same as 2x plus 6, and I don't like that 6 there. So my gut is telling me that I should go with this one, 2x plus 3. And some of you picked this one because so far everything that's inside the brackets has been opposite. So if your gut told you to pick the first one, your gut tells you to not go with your gut. So pick the second one, and maybe you're choosing this one. The right answer is, in fact, this one. We don't write it like this, but this one is not correct. So we're going to have to, and what we're going to do is at the bottom of this page, we're going to write a special note. So you got some space at the bottom. We'll write this down as a special note. When you have a horizontal stretch or compression or reflection, and a horizontal translation, you must write it in factored form. And what I mean by factored form is this idea that whatever the stretch or the reflection or the compression, whatever that number is in front of the x, has been factored out so the translation is alone with the x. And all of our examples up till now have been that way, and we talked about it a little bit in that first example. But this is the way that it has to be. And that can be very confusing and is a very easy place to make a mistake. In fact, the majority of the time if I say, oh, we got a +3, how much has that moved? It's moved to the left 1.5, right? In this case on the left, because it's not factored out. So you would have to factor the 2 out of the 3 first, and it would be x plus 1.5 in the brackets to describe it. So that's going to be something that's a little bit tricky. Okay, we are going to try some of these questions 4, 5, and 6 right now.